Okay viewers, I've got a couple of scores today. Got a nice old bakelite. These are used on the like along the wall, the foot strips along the wall. This is a Ringgrip. It's inside a series. Active there, neutral there, earth. 50 volt 10 amp AC. Made in Australia. I think these are from the late 50s, this one, this design. They will clean up alright. It's been underwater for a little bit, but the internals are still okay. There was a smashed up, buggered up window air conditioner, just way beyond repair. So anything I could salvage off it is just cord. It's in good nick. It's a 439 series Clipsal plug on it. That will just clean up alright, and I might replace this one. This is a great overkill for the NST. So that's going to go on there. Got this Wickedxe Switchmode battery charger. These types of battery chargers will not do anything unless you connect them to a battery. Then they'll start charging. But that's all you can use them for. You can't use them for power supplies or anything. I think it's got bad caps in it. This is just a cheap Wickedxe one. 3-stage 10,000 milliamp 12 volt automatic switch mode for charging 12 volt lead acid batteries only. So I'll try and repair that. If not, I'll get a good set of leads out of it. Also got these all came off a wrecked up caravan, by the way, but the same era as this one. They all use the same power points as this caravan does, as you can see here. This is the only double outlet one I found. This is a Ringgrip, category number SG11 series, Aussie made. So I'm going to clean this one here up. I'm going to install it in here so I can have a double outlet on my BAZ. I've got to get a junction box for it though, so they can have convenience having a double outlet for my BAZ. This is a Clipsal number 4DD series, made in Australia. This will be from the 60s. Bit of sun damage, but it'll clean up alright. Some architrave light switches. Here's some of the original wiring from that caravan. Or one of the auxiliary wires. As you can see, the rubber's just crumbled off. These are also Clipsal. Let's try and get the series number here. Haven't quite yet remembered these off by heart, the series numbers of these. Something 50N series. Oh, there you go. S/1/50N series. That one had a little clips broken off, but I'll fix that. But there you go, they'll be good to restore. Here's a nice little one. Nice old white bakelite one. Full of paint, but turpentine will clean that up really well. I'm going to stick this back in my little ballast box there. So now I can reuse that ballast box. That was my original one. You use a 10 amp kettle heating element. Alright, let's open this charger up, see what this is like first. Okay viewers, the stupid idea with this. When they mean indoor use only, they bloody well mean it. Remember the old transformer based ones, doesn't matter. This one, you bloody well got to use them indoors. The tiniest bit of moisture got in, and something's gotten burnt there. Something's gone bang. And the capacitors and everything look alright visually. Oops, little clamps come off the transformer there. Look on this side of the board, you can see where the water's been. And that's the primary side of the power supply. These little switching MOSFETs have gone bang, from what I can see. They're not very well soldered either. Some corrosion there. Some of the sensitive electronics, so there's diodes or something's probably got a water shorted out across it, and it's just shot a spark through them and either killed those diodes and all of these. So I reckon these are the problem. They would have got a spark of some sort, which is what killed it. We'll check those diodes anyway. But it's just it's bloody pointless. Why the hell would you need a Switchmode power supply battery charger? All these bloody limitations. The capacitors are Mobile brand. Never heard of Mobile. Little ones, what about the little ones? They're all made by Mobile. 2008, 16th to the 11th, 2008. That's where the battery indicator plugs in. RRHS 250 volt AC fuse, that's probably gone bang. I'll check that too. TL494 must be the heart and brain to this circuit. That's a power supply chip. This is pretty much a bloody modified version of a computer power supply. IOF48 MOSFET. There's a MBR 20100 on the board, but B201006. Main transformer that supplies a 10 amps. Little transistor in there, it looks like, or a zip tie or something. Looks like a TO, I think it's a TA92, this shaped transistor. Or something like that anyway. Can't remember the bloody transistor outline number. Potentiometer. At least it's got an at least there's a, this one's grounded. Oh, let's check some diodes. I bet they've damaged in one way or another. Okay, viewers, I checked those little diodes there, and they're fine. I gotta get these little insulating jackets off these high voltage main switching transistors and see what they are. I bet they've gone bang. Things like that don't like moisture anywhere near them. There's one of that's a middle leg, and that's got a hell of a lot of current that's blown the chaser off around it and desoldered itself, so I reckon that may have taken out that fuse too. Yep, these are just pants. On a farm like this, and you want to use them out in the field, they're just pants. Oh, that's how you get the bloody thing apart. The top slides out. Ah. Oh, viewers, I'm going to check this fuse. I wonder if that's actually popped. I wonder if I can get some more ones of these off a computer power supply to actually fix this. I might. If not, I get a good set of jumper leads out of it, and a good cord, and a nice looking case. So let's test this fuse. Alright, I set this up next to the multimeter so you can see and hear the beep. Continuity of this fuse, let's see if it's intact. No, she's gone bang. Yep, meter leads are good. Yep, fuse is blown. Yep, those main transistors got a hell of a kick up the arse from moisture going near them. If I can get these little high voltage insulating heat transfer jackets off them, I will check them and see if they're what part numbers they are. I just managed to chip that bloody ferrite too, getting this thing apart. If only I could have found this out earlier, would have made it a lot easier to pull it apart. Alright. Also, a big shout out and thank you to Wickedxe. David, his name is. He come across a heap of these. These are communications radio or communications modules using Landis Gyr E350 smart meters. These are what actually transmit your readings every half hour. This has got a bit of a dent there, so I've got two. So this one is probably going to be the one I'm going to pop. I'm going to mop that and NST it, and this one here seems to be in a bit better nick. So this is going to go in my Landis Gyr E350, the other smart meter I kept. This is going to go in there and see if it actually does anything. Let's have a good closer detailed look at it. Okay viewers, here's the other smart meter. I'm going to keep this intact as a check meter to test accuracy and see how good my these meters are over time. So this is a communications module. This is a, I think this must be the transmitter half here. This must be what a processing half. And this must be the actual radio transmitter in here, because it's all RF shorted and everything. Antenna. That little thing there is the antenna. Board antenna. Landis Gyr 849448 U series Zigbee module. It's got layer 4 in there. And the model of the transmitter is E35C type WIMAX communications module. Warning, extra low voltage. Ensure antenna is connected to the communication module prior to powering up. This is the antennas where the external antennas go on here. They rarely use these. This is the actual main antenna in here. That's the part there. Those pins actually plug in at the top of the meter. It's the main chip there. It's got MCIMX258CJM4, National Semiconductors JM19AD. Can barely bloody read it. It's so bloody small. 10D12. Put it the right way up so you can see it. Bloody glare, you can't read it. It's got 10D12NW101. Another shielded part there. Little inductor. A JH brand electrolyte capacitor. Never heard of that brand. Little surface mount. It's bloody technology to just making it smaller and smaller and smaller. 4.7 microhenry SMD inductor. Doesn't look too healthy, that chip. 130 B33. 100 microfarad 16 volt capacitor. There's a chip there, it's been snapped off the board, so this has been roughly handled. Get the other communications module out and just give you a demonstration of how they would have plugged into these things. Get that out. Stand that up, and that normally that just sits in like this. And there you go. The meter is now smart and it can communicate to other smart meters. And they stick out the back through there. There's a little. They don't really provide you much room to stick the antenna out through the back of these. And that goes over the top. I'll inspect that later on and see if that's all intact, and we'll see if the smart meter reads it, that it's the WLAN light comes on. Interesting to note if it does or not. Now, to make these things a bastard to use and put back together. Alright viewers, that's enough for today, so next video I'll continue on with this. Thanks for watching.